Well, hello, seventh graders. Let's get it started on some proportional and non-proportional relationships. But before we get started, I want you to see if you can answer this first question in the table. So the launch is Miss Brenneman is planning a year-end pizza party for her students. Pizza Shuttle offers free delivery and charges $8 per medium pizza. Go ahead and fill in that table for 1 through 5 pizzas. Go ahead and pause. Alrighty, so in this table, take a look. You have $8, then 24 and 32, and then finally with $40. Then we're going to look at some ratios based on that table that you created. So if you did happen to have an incorrect number, go ahead and fix it now. For the ratio, for each number of pizzas, fill in the boxes. In this instance, it's just the blanks to write the relationship of the cost and number of pizzas as a ratio in simplest form. So taking a look at just this point right here, this is the point. Number of pizzas is going to be our X variable. Total cost is going to be our Y variable whenever you have a table like that. If ever you have a table up and down like this, that's going to be your X. This is going to be your Y. So when I compare these two variables, the total cost, notice that that's up in the numerator. So therefore that's like the Y value. And then this down here is the X value. So essentially what we're doing here is we're taking the Y value divided by the X value. So when I take 16 divided by 2, I get 8 over 1, or just 8. And then for that next value, if this were a value that I am plotting, this is like 3 comma 24. But for this instance, for ratios, we're taking the Y, which is 24, divided by the X, which is 3. When I divide those out, I still have 8. And then finally, I have 32, and I know that that denominator, or that X value, is going to be 4, because we know X comma Y, which is like 4 comma 32. But again, I'm noticing in my ratio that I'm taking Y divided by X every time. 32 divided by 4 does in fact still give us 8, and that's 8 over 1. And then lastly, if I have a denominator of 5, that's our X value. So then our Y value for that point, X comma Y, which is 5 comma 40. I know that 40 needs to go up in the numerator for the Y value, and 40 divided by 5 is still, in fact, 8 over 1. So what did you notice? Hopefully that each ratio simplified is 8 over 1. All right, now let's get into the nitty gritty for the vocabulary. A proportional relationship is when two quantities have the same constant ratio or unit rate. Same thing. So we've been dealing with unit rates thus far. A constant, you don't have to necessarily call it a constant ratio, but we're just looking for that constant for it to be the same. So circle the table that represents a proportional relationship and identify the constant. So to find our constant, to see if it is constant, again, we're doing what we did up above, that Y divided by X. That's kind of our magic formula, if you will. So then we're going to do that each time. Teachers is going to be our X value. Students is going to be our Y value. So therefore, we are taking 92 divided by 4 in this instance. And when we do that, it looks like we get 23. And then when I do that again for the next value, 115 divided by 5, it looks like I still have 23. So for all of these numbers, you need to go ahead and check every single one of them. So when I do 161 divided by 7, I still, in fact, have 23. So don't be done. You want to continue for every single one of these. So 230 divided by 10, I do get 23. And then lastly, we get 330 divided by 15 take a look. This one's 22. So because here, this one right here is different, this one is not proportional. You would say not proportional. So the reason there is because there is no constant value. Sure, it was constant across the board until that last ordered pair, or that last set of values, that 15 comma 330. When I divided those two things out, I did get a different number. So same idea with this one. we got X, we got Y. We're going to go ahead and divide each one of these out. 9.2 divided by 2. We're going to take 13.8 divided by 3, 23 divided by 5, and 41.4 divided by 9, and 46 divided by 10. Alrighty, and every time I do that, I'm going to go ahead and save us some time. We do end up with 4.6 for each one of these. 4.6 and 4.6, 4.6. So therefore, you would say this one is proportional. And then up above it says if it is, identify the constant. So right here, you're just going to say the constant equals 4.6. And that's 4.6 feet per second. So we're always going to start with that Y because that's your numerator. And then we're going to go down to our X, which is seconds. And then before we turn these notes over, I just want to direct your attention to one more vocabulary word. You may see this every now and then as direct variation. And so direct variation, that vocabulary definition is when two variable quantities have this constant ratio. And the constant ratio is just called the constant of variation, or just the constant. So we're going to write this as the same as a proportional relationship, because I just want you to be aware that you may see it as a proportional relationship. You may see it as direct variation, but either way, it has to have a constant. So there's that constant whenever we take Y divided by X. All right, let's turn our notes over. Alrighty, so the next example that we're going to see is Andrew earns $18 per hour for mowing lawns. Is the amount of money he earns proportional to the number of hours that he spends mowing? If so, we're going to identify the constant and fill in the table. If not, we're going to explain why not. So let's take a look. Let's test this out. So if I mow 0 lawns, does Andrew get any money? Well, the answer is no. So therefore, we make $0. But if I mow 1 lawn, Andrew makes $18. If I mow 2 lawns, I know that it's going to be $18 more than that, so 36. If I mow 3 lawns, I know that it's going to be $54. And then if I mow 4 lawns, I get $72. So therefore, the constant here, well, let's just double, triple check. But again, you would take 18 divided by 1. You would take 36 divided by 2, 54 divided by 3, and 72 divided by 4. I'm going to go ahead and help us out again that there is a constant is 18. However, let's talk about one thing real quick. So I purposely started at this ordered pair. So at 0, 0, because if our, eventually in the next section, we are going to have to graph these scenarios. And if our graph goes through 0, 0, or the origin, I know that it is a direct variation equation or a direct variation scenario situation. I know that 0 divided by 0 cannot be calculated because anything divided by 0 is undefined. So that's why I went ahead and just skipped that point. But I still wanted to show you that in a table, if it goes through 0, 0, or if I don't mow any lawns, I have 0 money earned, that it is going to be a direct variation equation. All right, so keeping that in mind, I'm going to move down to example 2. So tickets for less, it charges $7 per baseball ticket plus a $3 processing fee per order. Okay. Then it says, is the cost of an order proportional to the number of tickets ordered? Okay, let's take a look. First off, my apologies. This is the incorrect labeling of our table, so go ahead and cross those off. The correct labeling should be number of tickets. And then right down here, it's going to be the total cost. Sorry about that. So for one person purchasing tickets, I know that for one ticket, I have to pay $7 for the for the ticket and or plus a $3 processing fee. So I'm purchasing one ticket, so therefore $7 plus $3 more is $10. Okay, so then if I get 2 tickets on that same order, I know that it's $7 per ticket. So 7 times 2 is 14, and then plus that $3 processing fee. So 14 plus $3 more is $17. And then on that same order, let's pretend like I actually purchased 3 tickets. So 3 times 7 is going to be $21 plus that processing fee, so $24. And then for 4 tickets on that one order, instead I'm going to take 4 times 7, get 28 plus 3 more dollars is 31. And then lastly, I'm going to try it with 5. So 5 times 7 is $35 plus 3 more dollars is $38. All right, now let's check this out to see if there is a constant. That's what I'm trying to find. So when I take 10 divided by 1, I know that I get 10. And then when I take 17 divided by 2, wow, I already automatically know that it's not going to equal 10. That's what that symbol means. This does not equal. So therefore here you would say this is not proportional. And the reason that it is not proportional is because there is no constant value. So when it is proportional, all you have to do is tell me the constant because you know it's all the same. And then if it's not proportional, you're just going to say, nope, there's no constant. It does not equal the same across the board. So I was going to start with 0. So if I were to start with 0 here, what I was looking for was, would there be a 0 in the y value, or would it be a number that's not in that y value? So here in this scenario, it's not as cut and dry because I was looking for 0,3, which means that there's $3 processing fee per order, but we actually didn't order anything. So in this instance, actually, it does go through the origin. However, even though it goes to the origin, your graph is going to look like it'll start at the origin here, but then it'll like go up like this. And so it's not going to be linear. And again, this is just combining this lesson with next lesson, which is more so graphs. So we're going to take a look at that a little bit in more detail on the next section. Okay, and then lastly, we are going to fill in the table to create a proportional relationship. So whenever you have a table like this, you're going to find a set of values that you know both the x and the y value. So therefore, I'm going to use this one right here. Because we're looking for a proportional relationship, I'm going to take 136 and I'm going to divide that by 8. And I get that my answer there is 17. So therefore, my constant equals 17. And then with that information, I'm going to fill in the rest of it. So if I know that I want 3 tickets, whatever this table may be, I'm going to take 3 times 17. And when I do that, I get 51. And same thing over here, 11 times 17. And when I do that, I get 187. Okay, but then what happens when I don't know the ticket, but instead I know the total cost? So because I went from x to y and I multiplied by 17, the opposite of multiplying by 17 is going to be dividing. So as I go from y to x, we are actually going to divide by 17. So when I take 255 divided by 17, I get that this should be the number 15. And then 102 divided by 17 gives us the number 6. So on your quiz, on your test, I am looking for these blanks and hoping that, okay, to get from x to y, I'm multiplying. But then to get from y to x, I'm dividing here. All right, go ahead and pause this video and try example 4 on your own. Okay, take a look. I went ahead and multiplied the x values by 30, that constant, to get 90 and then 360. And then once I have the y values, I divided by 30 to get 4 and 7. All right, so in summary, in a table, how do you determine whether a situation is proportional or not based on a table? So we know that in a table, y divided by x has to be the same. Or constant. All right, good luck on your problems.